Here we are going to see how we can graph piecewise functions with quadratics. And if you look at the first problem here, you have a linear function, the first one. The second one is linear. The third one is a quadratic piece. And let's start with the number one. So I'm just going to label them. So I start with, this is number one, I'll call this number two, and this one is number three. So if I start with the first one, it says I just need to, since I'm given the endpoints, it's a line segment, I just need to plug in the points. So when x is -4, I plug it into the equation, I get 4. So -4 gives me 4 right there, and then that's going to be a closed circle. And then the next one, I plug in -2 into y is equals to -x, and I get 2. So -2 gives me 2. That's going to be a closed circle, so I just connect those two. Then I go to the next one. It's also a segment, a line segment. I plug in -2, -2, -3. So that's going to be -5. Is it going to be an open or closed circle? It's going to be closed. Then I plug in the other endpoint. So 1 -3. So that's -2. So when x is 1, it's going to be -2. Not actually. 1 -2, so right there, and that's going to be an open circle, so that's also a segment. And then from 1 and higher, it's going to be the quadratic piece. Let me use a different color here so that it starts out. So I plug in 1 into the equation, so that's 1 -2. So I get -1. So that's going to be a closed circle right there. Because when x is 1 squared -2, okay. And then I plug in 2. So 2, when I plug in 2, what do I get? 2 squared -2. So I get 2. So that's going to be 2. So what about if I plug in 3? 3 squared -2, so I get 7. So over there, and I don't think the other points are going to fit. So remember, this is not a line, it's a quadratic piece. Just need to join it with a smooth curve. So, and that's how the piecewise function is going to be. Then let's find the domain of this function. So the domain, so it starts at -4 and keeps going to infinity. So -4 is included. What about the range? The lowest is -5 and to infinity. Is -5 included? Yes. And now we just need to evaluate the function at -4. And when I plug in -4, I get 4. When I plug in -2, I get 2. Remember, we already did those. When I plug in 1, that's how I got -1. Okay. We do another one. So this one has 2 pieces. So when x is -2 and lower, so I plug in -2 into the first one, and when I plug in -2 here, so I get 3. So -2, 1, 2, 3, open circle. Now I just need values less than -2. So then I'm going to plug in -3. So x is -3. What is y? Y is going to be 2. -3. I get -3. 1, 2, 3. Then I get 2. And I can see the slope is 1. And that just keeps going. And we go to the quadratic piece. So I'm going to plug in -2. So what do I get when I plug in -2? So -2 squared plus 2 times -2 plus 3. And this is 4. That's going to be 3. So -2 get 1, 2, 3. Oh, that closes that circle. Okay, so -2. Okay, now I need another value which is going to be greater than -2. So let's plug in -1. -1 squared plus 2 times -1 plus 3. So this is 1 minus 2 plus 3. So we get 2. So -1 becomes 2. So what y becomes 2? So what about 0? When x is 0, we get 1, 2, 3. What about when x is 1? When x is 1, so it's going to be 1 squared plus 2 plus 3. So that's going to be 6. Okay, 1 plus 2, so that's going to be 6. And that's going to be there. And those are enough values to give us a sketch of how the parabola is going to be. So that's how the piece, well, that's close. That's how the piecewise function is going to